Alright guys, Math 1513, College Algebra at Northern Oklahoma College, Chapter 2, Section 2, we're evaluating functions. Okay, back in junior high, a function looked like this. Let's say, for example, y equals x plus 1. That's nice and simple, not scary at all. Okay, you're in college now. Now in college, they replace the y and they call it f of x. Everything else stays the same. And we say f of x. That's how you say it, f of x. All that is a name for this particular function. We call it the f function. We say f of x. We could have just as easily called it g of x, or h of x, or any other letter you choose, all right? It's just a name. F is the one they use most commonly. All right, so I'm going to use this nice, easy formula, this nice, easy function, f of x equals x plus 1. And what am I going to do? I'm going to run a few x's through and see what happens. For example, what if I want x to be 0? Well, I just take out the x, I write f of 0, and I'm saying, what is f of 0? I'm saying, what is the function f when I run 0 through it, when I replace x with 0? So I'm going to take my x out, put a 0 in, and it looks like that. Now just do the math. So f of 0 equals, what's 0 plus 1? That's 1. Nice and easy, not scary at all. Okay, what would this look like in a table? Well, back in junior high, our table looked like this, a nice little x and y. What was our x? Our x was 0. We put in 0. What did we get out? We got out a 1. If you wrote it as an ordered pair, it looked like that. Now remember, we're not in junior high anymore, so I got to mark out the y. Whoops, I don't want it to look like an X. I'm just going to mark it out because now we don't call it Y anymore. We call it f of x. I know, it sounds complicated, but that's what we do in college now. You guys are in college. What about f of 1? So I'm going to take the x out. I'm going to put in 1. That means take the x out. Remember to use parentheses. Put in a 1. Don't forget the plus 1 on the end. So what is f of 1? What is the function f when I run 1 through it? Well, that's going to be 2 because 1 plus 1 is 2. So let's put it in the table. I put in a 1 for x. My output was a 2. My domain was a 1. My range was a 2. My input was a 1. My output was a 2. However you want to say it. How's it look as an ordered pair? Like that right there. Let's try one more. Let's throw in a negative. What about f of negative 3? Now this is where you really need to use the parentheses later on to make sure that your negative doesn't mess up your calculation. So I use parentheses, I take out the x, I put in a negative 3, don't forget the plus 1 on the end. And what is the function f when I run negative 3 through it? So f of negative 3 winds up equaling negative 2. How's it look in the table? I put in a negative 3, I got out a negative 2, and that's what it looks like as an ordered pair. Alright, now before we leave this topic, I'm going to show you, I love the graphing calculators, and if you use a graphing calculator on my test, it's not going to hurt my feelings a bit. I like it that you can use it, but the bad news is, for the graphing calculator, they go back to junior high and they call f of x a y. So on the graphing calculator, I'm going to put this in as y equals x plus 1, and let's do that. Okay, so here's my graphing calculator. Up here I've put in the equation y equals x plus 1. Watch over here. It's going to spit out a table of values as soon as I hit graph. So here we go. Whoops. Graph. Okay, close the ink layer. Graph. There we go. There's our line. So there's our linear equation. Linear means line. And over here, we have all of our ordered pairs. Now remember, we don't use y anymore. We use f of x. So what is f of negative 5? You can think of it this way. F of negative 5 equals negative 4. When we put negative 5 into the function, we get a negative 4. What's f of negative 2? F of negative 2 equals negative 1. What's f of 0? Well, f of 0 equals 1. Think of it that way. So if you can pull up a table on your graphing calculator, you can run all those values through your f function. Okay, you guys knew it couldn't be that easy, so of course the book makes it a little more difficult. What about something like this? J of t equals 3t squared minus t, and they want to throw something weird in, like 1/3. Maybe they want to know what 1/3 is when you run it through the function j. So remember, it's very important to use your parentheses, okay? So I put parentheses around the t. I'm going to take the t out and put 1/3 in. So 3 parentheses 1/3 squared minus parentheses 1/3. Just get in the habit of using parentheses just for organization. So j of 1/3 is, all right, 3 times 1/3 squared. What do I do? Multiply or exponents first? You do exponents first. That's order of operations. So what I'm going to do is I'm going to do my exponent. I'm going to raise 1/3 to the second power. So 1/3 squared is 1/3 times 1/3, which is 1/9. I'm going to leave it in parentheses. Now I've taken it to the second power, so my exponent's gone. My 3 is still in front, and my minus 1/3 is in back. Now I took the parentheses off the 1/3 because they really weren't doing anything. You want to leave the parentheses on, especially when you're squaring stuff and multiplying stuff. But this 1/3 out here on the end is pretty much not doing anything. It just has a minus in front of it, so I put that minus in front of it and drop the parentheses. Next step, j of 1/3. Now I got a choice between, I could multiply or I could minus. Order of operations tells you to multiply first. Your calculator will do this for you as well. Your calculator usually knows what to do first. So 3/9 minus 1/3 if we're doing it by hand. Finally, j of 1/3 equals 3/9 minus 3/9. And our final answer is j of 1/3 equals 0. All right, that's if you do it by hand. Now, of course, you can plug it into the graphing calculator. You might have to change a few values on your graphing calculator so that you can get a 1/3 to come up. So that's something you might want to learn how to do before the test. If not, just do it by hand like this. Okay, let's get a little weirder. What if they want to know what negative c would be if you ran it through the j function? Well, all that means is take your t's out and replace them with negative c's and simplify. First thing I want to do is I want to make sure that I put parentheses around the t, especially since I'm squaring. Okay, if I'm squaring a t and I put a negative c in there, I'm going to have to square that negative. So we want to make sure you use the parentheses so that it squares properly. All right, here's what I got. I took my t's out. I'm going to replace them with my negative c, okay? Let's simplify. So j of negative c equals, okay, I got some choices here. I can multiply, I can raise it to a power, or I can subtract. All right, order of exponents says do your powers first. So what I'm going to do is I'm going to square the negative c. When you square the negative c, that's negative c times negative c, gives you a positive c squared. I still have the 3 times in front of it. So negative c squared is c squared. I still have times 3. Now look at the minus a negative c. You guys know that minus a negative turns into plus. So out here I have plus c. So I squared the negative c, got c squared. I still have times 3. I still have plus c on the end. All right, what else can I do? The only other thing I can do is just maybe leave that dot out and simplify it, make it look as clean as I can. All right, let's get a little bit weirder. What if they want to know what x plus 1 is when you run it through the function j? Okay, all I'm going to do is take out the t and replace it with x plus 1 and simplify and see what happens. So parentheses around my t. I have 3 parentheses squared minus parentheses. I just took the t's out. Now I'm getting ready to put x plus 1 in. So I put in x plus 1 in that t parentheses, and I put x plus 1 in that t parentheses. Now the rest of it is just simplifying. So x plus 1, when I run it through the j function, equals, all right, I got some more choices here. I can multiply, I can raise to a power, or I can subtract. PEMDAS, please excuse my doing at Sally. The order of operations says do your exponents first. So what we're going to do is we're going to square this parentheses. All that 2c's, all this exponent c's is this group right in front of it. So it's going to square the x plus 1. Now if you want to write this out the long way, that's going to be 3 times. Now x plus 1 squared is x plus 1 times another x plus 1. That's x plus 1 squared. We'll multiply that out on the next row. Minus my final x plus 1 on the end. Alright, so we've done our exponents. What's next? We have a choice between multiplication here, and subtraction here. You always do multiplication before you do subtraction, so let's multiply. Okay, multiply. I could multiply the 3 out, but that's kind of the hard way. I'm going to multiply the x plus 1 times x plus 1 first. Alright, and I have this 3 times x squared plus 2x plus 1. Alright, choice. I can multiply or I can subtract. You always multiply before you subtract, so we're still multiplying. Alright, and I have 3x squared plus 6x plus 3. Now while I'm at it, I'm going to go ahead and distribute this negative. Everybody in the parentheses gets that negative. So the negative times the x gives me a negative x or a minus x, and the negative times a positive 1 gives me a negative 1 or minus 1. Same thing. Alright, the last thing we need to do is just look for any like terms that we can add together. And this is what it ends up like. 3x squared, we didn't have any other x squareds to add to it, so it came down. I put the 6x and the negative x together and got 5x. And I put my positive 3 and negative 1 together and got positive 2. So when you run an x plus 1 through the j function, you say j of x plus 1 is, and this is what you get. So when you run an x plus 1 through the j function, you get 3x squared plus 5x plus 2. Okay, last one. What if we want to run an x plus h through the j function? That just means take out the t and put in x plus h and straighten it all out. So, rule number 1, put parentheses around your t's or your x's or your v's or whatever letter happens to be up there. Because we're getting ready to take that t out and put something else in. We're getting ready to substitute. Alright, so I have 3 times my parentheses, which I'm going to square, minus my parentheses. I took the t's out. I'm going to put in the x plus h. So all I'm doing is replacing my t with x plus h. Okay, what do? Do I multiply by 3? Do I square? Do I subtract? Remember, do exponents first. So we are going to square, the x plus h. Okay, here's where we're at. X plus h squared is x plus h times another x plus h. So I have a choice between multiply here, and subtract here. I'm going to do my multiplication first. Alright, I've multiplied out the x plus h times x plus h and got x squared plus 2hx. You want to go alphabetical, so I went h before x. And then plus h squared. Now I'm going to go ahead and distribute the negative while I'm at it. So I have minus x minus h. Okay, next is multiply. Alright, so multiply out the 3. You got 3x squared plus 6hx plus 3h squared. Last step, just look for any like terms that you can put together. And I got ahead of myself. I looked, and there are no like terms. So we're just going to stop right there. There's our answer. So when I take x plus h and run it through the j function, I get that mess right there.